In the infinite cathedral of space, where silence reigns absolute and darkness stretches beyond comprehension, a single question whispers through the cosmic void. What if something out there is building solar systems? Picture the vastness between stars, not empty, but pregnant with possibility. Here, where no earthly sound has ever traveled, where time moves like honey through frozen dreams, something extraordinary drifts through the darkness. Its name is 3I Atlas, and it glows with an ethereal neon green light that seems almost alive. This is not the harsh, violent brightness of a star. This is something gentler, more mysterious, a luminescence that speaks of chemistry unfolding in the depths of space, of processes we barely understand, of origins that stretch back to star systems we have never seen. The object moves with purpose through the interstellar medium, carrying within its frozen heart the very elements that make worlds possible. Hydrogen and oxygen dance together in crystalline lattices, while organic compounds, the building blocks of complexity itself, wait in suspended animation for their moment of awakening. But here, in this moment of perfect cosmic solitude, a more profound question emerges from the depths of scientific wonder. What if this visitor from another star system isn't simply drifting aimlessly through space? What if it carries with it not just the remnants of its distant home, but the seeds of something entirely new? As 3I Atlas continues its journey through our solar system, releasing plumes of vapor that catch the distant sunlight like prayers made visible, astronomers around the world find themselves confronting a possibility that challenges everything we thought we knew about how planetary systems form, how life spreads through the galaxy, and whether we are truly alone in this vast cosmic theater. The green glow intensifies as internal processes, mysterious, unexplained, continue to unfold within its ancient core. Each particle of vapor that escapes into space carries with it the chemical signature of another world, another time, another corner of the galaxy where stars once burned and planets once danced. This is the story of 3I Atlas, but it is also something more. It is the story of how the universe might plant the seeds of tomorrow, how stellar death becomes planetary birth, and how a single question, whispered in the darkness between worlds, can illuminate the very nature of cosmic creation itself. July 2025. The world below continued its ancient rhythms, seasons changing, tides flowing, life persisting in countless forms across Earth's surface. But high above, in the realm where only telescopes can reach, something unprecedented was about to unfold. The first detection came not with fanfare, but with the quiet precision that defines modern astronomy. Deep in Chile's Atacama Desert, where the air is so thin and dry that it barely interferes with starlight, the Atlas Survey Telescope recorded a faint smudge of light moving against the stellar background. At first, nothing seemed extraordinary about this discovery. Astronomers encounter moving objects regularly: asteroids, comets, fragments of ancient collisions that have been wandering through space for millions of years. The initial observations suggested just another piece of cosmic debris, perhaps knocked loose from the Kuiper Belt, following a predictable orbit around our sun. But as nights passed and more observations accumulated, subtle anomalies began to emerge from the data like whispers in the dark. The object's brightness flickered in patterns that didn't match known cometary behavior. Its spectral signature, the fingerprint of light that reveals chemical composition, contained unexpected elements, ratios that seemed almost foreign. Most puzzling of all was its trajectory. While it followed the gravitational choreography expected of any object in our solar system, there were minute deviations, tiny accelerations that couldn't be explained by the sun's pull alone. These weren't random variations. They showed a consistency, a pattern that suggested something more complex was occurring within the visitor's core. Dr. Sarah Chen, working the late shift at the Mauna Kea Observatory, was among the first to notice these peculiarities. As she analyzed the spectroscopic data streaming across her monitors, she felt a familiar tingle of scientific curiosity, mixed with something deeper, the recognition that nature was presenting humanity with another riddle to solve. The object received its official designation, 3I Atlas, marking it as the third confirmed interstellar visitor to our solar system. But already, in the quiet conversations between researchers and the careful language of preliminary reports, a sense was growing that this designation might prove woefully inadequate for describing what they were actually observing. Meanwhile, automated tracking systems around the world locked onto the visitor's position, creating a continuous stream of data that would, over the coming weeks, transform scientific understanding of what was possible in the realm between stars. Each photon of light that traveled the vast distance from 3I Atlas to Earth's telescopes carried information that challenged conventional wisdom about comets, about interstellar space, and about the fundamental processes that govern matter in the cosmic dark. The stranger had arrived, but its secrets remained locked in patterns of light and shadow that would take months to decode. As August nights deepened and 3I Atlas continued its journey through the inner solar system, astronomers made a discovery that defied every model they had constructed about how comets behave in the cold depths of space. The object was gushing water into the void like a celestial fire hose. Picture the scene unfolding in the darkness between Mars and Jupiter, a region so distant from our sun that ice should remain frozen solid for millennia. Here, where solar radiation is barely a whisper compared to the fierce heat that Earth receives, 3I Atlas was somehow generating enough energy to vaporize massive quantities of its internal ice reserves. The numbers were staggering. Spectroscopic analysis revealed that the visitor was ejecting approximately 40 kilograms of water vapor every second, a rate so prodigious that it created visible jets streaming away from its nucleus, like ghostly tentacles reaching into space. These weren't the gentle, intermittent puffs typical of distant comets beginning to warm. This was a sustained, powerful outflow that spoke of internal processes operating at temperatures and pressures that shouldn't exist so far from any heat source. Dr. Elena Vasquez, studying the phenomenon from her laboratory at the European Southern Observatory, found herself staring at data that seemed to violate the fundamental physics of frozen bodies in space. "Comets are supposed to be dormant at these distances," she murmured to her colleague during one of their late-night analysis sessions. "What we're seeing is like discovering an iceberg melting in the Arctic winter." The mystery deepened as infrared observations revealed that the water vapor wasn't the only thing escaping from 3I Atlas. Complex organic molecules, carbon-based compounds that form the chemical foundation of life, were also streaming away from the object in concentrations that suggested a rich, diverse internal chemistry was actively unfolding within its core. But perhaps most puzzling of all was the energy source driving this extraordinary activity. Solar heating alone couldn't account for what they were observing. Even accounting for the most efficient absorption of distant sunlight, the energy budget didn't balance. Something else, something internal, was generating the heat necessary to sustain this massive outflow of vapor and organic material. Some researchers began to speculate about radioactive decay within the object's core, perhaps from elements created in the dying moments of its parent star system. Others wondered if chemical reactions, triggered by the object's entry into our solar system, might be generating heat through processes not yet understood. As the data accumulated night after night, one thing became increasingly clear. 3I Atlas was not behaving like any comet in Earth's experience. It was something else entirely, a phenomenon that challenged the very categories astronomers use to understand visitors from the depths of interstellar space. The implications were profound, and they were only beginning to emerge. In the crystalline silence of deep space where temperatures hover just above absolute zero, and matter exists in its most pristine form, the vapor streaming from 3I Atlas carried with it something far more precious than mere ice and dust. It carried the chemical memory of another star system, a molecular archive of conditions that existed around a distant sun, perhaps billions of years ago. Each droplet of water vapor that escaped into the void represented a fragment of cosmic history. The hydrogen atoms, forged in the first moments after the Big Bang, had traveled through space and time to become part of this interstellar wanderer. The oxygen, created in the nuclear furnace of a massive star and scattered into space during its final violent death, brought with it the elemental gifts that make life possible. But it was the trace compounds that truly captured the imagination of researchers studying 3I Atlas. Embedded within the ice matrix were organic molecules of startling complexity. carbon chains that hinted at chemical processes far more sophisticated than the simple freezing of water in the interstellar medium. Dr. Michael Torres, a specialist in astrobiology at the California Institute of Technology, spent countless hours analyzing the spectral data with an almost reverent attention to detail. "We're not just looking at ice," he explained to his research team during one of their weekly meetings. "We're looking at a chemical library from another world, possibly even another era of galactic evolution." The molecular signatures told a story that stretched across vast distances and unimaginable spans of time. Some compounds appeared to be the products of organic chemistry that could only occur in the presence of liquid water, suggesting that 3I Atlas might have originated in a system where conditions were once suitable for the kinds of complex chemical reactions that, on Earth, led to the emergence of life itself. Other molecules seemed to bear the fingerprints of high-energy environments, perhaps the aftermath of stellar explosions or the intense radiation fields that exist near the centers of galaxies. These compounds spoke of cosmic violence transformed into cosmic creativity, of destruction that becomes the foundation for new forms of complexity and beauty. As the vapor continued to stream away from the visitor's core, creating a tenuous atmosphere that caught and scattered sunlight in patterns of ethereal beauty, astronomers began to realize they were witnessing something unprecedented: the real-time dispersal of interstellar organic matter throughout our solar system. The implications were staggering. If objects like 3I Atlas regularly traverse the galaxy, carrying with them the chemical building blocks of complexity and life, then the universe might be far more interconnected than anyone had previously imagined. The boundary between star systems, once thought to be vast and insurmountable, might actually be crossed regularly by messengers bearing the gifts of cosmic chemistry. In the gentle glow of vapor trails stretching across millions of kilometers of space, humanity was witnessing not just the death of a comet, but potentially the birth of new possibilities for understanding how matter, energy, and complexity flow through the cosmic web that connects all things. Deep within the specialized laboratories where starlight is dissected into its component wavelengths, a different kind of mystery was emerging from the data streams flowing in from telescopes around the world. The spectroscopic signature of 3I Atlas, that unique fingerprint of light that reveals the chemical composition of distant objects, contained patterns that didn't quite match anything in the extensive databases of known comets, asteroids, or interplanetary debris. Dr. Kenji Nakamura, working late into the Pacific night at the Subaru telescope, first noticed the anomalies while comparing 3I Atlas spectra with reference samples from the solar system's most well-studied comets. "There's something here that doesn't belong," he whispered to his colleague, highlighting specific absorption lines that appeared at wavelengths where they had never been observed before. The differences were subtle but consistent. Certain molecular ratios fell outside the expected ranges for objects formed in stellar environments similar to our own sun. Some isotopic signatures suggested processes that might occur in the gravitational chaos near galactic centers, while others hinted at chemical pathways that could only unfold in the intense radiation fields surrounding massive stars in their final evolutionary phases. Most intriguing of all were the organic compounds that seemed to exist in combinations never before observed in natural samples. These weren't random collections of carbon-based molecules. They showed organization, structure, patterns that suggested they might be the products of systematic chemical processes, rather than the chaotic mixing typical of primitive solar system materials. As weeks passed and more observations accumulated, the picture that emerged was of an object whose chemistry bore the hallmarks of multiple stellar environments. It was as if 3I Atlas had been assembled from materials that originated not just in one distant star system, but in several, a cosmic traveler that had somehow acquired components from different regions of the galaxy during its long journey through interstellar space. The temperature profiles added another layer to the mystery. While the object's surface remained frigid, consistent with its distance from the sun, there were indications of warmer regions within its interior, zones where chemical reactions might be proceeding at rates that defied conventional understanding of how frozen matter behaves in the cosmic cold. Some researchers began to speculate about the possibility of internal heat sources, perhaps radioactive elements with decay chains unknown in our solar system, or chemical reactions powered by the slow release of gravitational binding energy as the object's internal structure gradually reorganized itself in response to tidal forces. But it was the discovery of what appeared to be artificially pure isotopic ratios in certain key elements that truly challenged conventional explanations. In nature, isotopes typically occur in predictable proportions that reflect the nuclear processes in which they were created. The ratios observed in 3I Atlas suggested levels of purification that were difficult to achieve through natural processes alone. As the data continued to accumulate, painting an ever more complex picture of this interstellar visitor, one question began to dominate the discussions in observatories and research centers around the world. What kind of environment could have produced an object with such unusual characteristics? And more provocatively, what kind of processes, natural or otherwise, could account for the systematic organization visible in its chemical composition? The answers, if they existed, lay hidden in the gentle glow of vaporizing ice and the patient analysis of light that had traveled across the galaxy to reach human instruments. On a crisp autumn morning in Cambridge, Massachusetts, while the leaves of Harvard Yard painted themselves in shades of gold and crimson, Professor Avi Loeb sat in his office overlooking the historic campus where centuries of scientific revolution had unfolded. The email that would change the trajectory of 3I Atlas research had arrived overnight, carrying with it spectroscopic data that would challenge not just conventional wisdom about comets, but fundamental assumptions about the nature of interstellar visitors. Loeb, whose name had become synonymous with bold scientific speculation and rigorous intellectual courage, was no stranger to controversial ideas about objects from beyond our solar system. His previous work on 1I Oumuamua had established him as one of the few mainstream astronomers willing to seriously consider possibilities that others dismissed as science fiction. But as he studied the preliminary data on 3I Atlas, something deeper than mere scientific curiosity began to stir in his methodical mind. The patterns emerging from the observations weren't just unusual, they were systematic, organized, purposeful in ways that natural processes rarely achieve. "Every anomaly tells a story," he murmured to his research assistant, Dr. Sarah Kim, as they reviewed the latest observations together. "The question is whether we are brave enough to listen to what this story is trying to tell us." The water vapor emissions so far from any plausible heat source. The organized chemistry, suggesting processes more complex than random stellar formation. The isotopic ratios that hinted at purification methods unknown in natural environments. Each piece of evidence considered alone might be explained by exotic but natural phenomena. Taken together, they painted a picture that challenged the very foundations of how scientists thought about objects traveling between the stars. Loeb's approach to the mystery was characteristically methodical. Rather than immediately proposing radical explanations, he began by systematically eliminating conventional possibilities. Could outgassing be sustained by radioactive decay? The energy budget didn't support it. Could chemical reactions provide the necessary heat? The molecular inventory suggested otherwise. Could tidal forces from the sun's gravity generate sufficient internal energy? The mathematics were unforgiving in their clarity. As each natural explanation proved insufficient, Loeb found himself confronting a possibility that few of his colleagues were willing to consider seriously. What if 3I Atlas wasn't entirely natural? What if it represented something more complex, not necessarily artificial in the sense of being manufactured, but perhaps structured or organized by processes that transcended the random mixing typical of primitive solar system formation? The idea wasn't entirely without precedent. Throughout the cosmos, nature regularly produced structures of stunning complexity and organization, from the spiral arms of galaxies to the intricate architecture of biological systems. Perhaps the boundary between natural and artificial wasn't as clear-cut as human experience suggested, but Loeb was careful to frame his emerging hypothesis in terms that honored both scientific rigor and intellectual humility. Rather than claiming certainty about 3I Atlas's origins, he began to ask different questions. What would it mean if interstellar space contained objects whose organization exceeded what current models could explain? How might such objects form through processes not yet understood by human science? As winter settled over New England and 3I Atlas continued its journey through the outer solar system, Loeb's team began to develop a research program that would approach this mystery with the seriousness it deserved. and the open-mindedness that genuine scientific inquiry demanded. The year 2017 had gifted humanity with its first confirmed visitor from interstellar space, a dark, elongated object that tumbled through the inner solar system like a cosmic cigar, reflecting sunlight in patterns that defied easy categorization. One-eye Oumuamua, named with the Hawaiian word for scout or messenger from afar, had arrived without warning and departed, leaving behind more questions than answers. As Loeb's team delved deeper into the 3-eye atlas data, the parallels with that first interstellar visitor became impossible to ignore. Oumuamua had moved through space with subtle accelerations that couldn't be explained by gravitational forces alone. It had reflected light in ways that suggested an unusually dense metallic composition, or perhaps a surface unlike anything found in our solar system. Most puzzling of all, it had produced no visible tail or coma despite passing close enough to the sun to vaporize significant quantities of ice. The scientific community's response to Oumuamua had been predictably conservative. Explanations were proposed that maintained the object within the comfortable boundaries of known physics: outgassing from previously undetected ice deposits, unusual rotation periods that created optical illusions, or exotic but natural compositions that might occur in the violent environments where stars are born and die. But Loeb had been among the few researchers willing to consider a more provocative possibility. In papers that generated both intense criticism and grudging admiration from colleagues, he had suggested that Oumuamua's behavior might be consistent with artificial origin, perhaps a light sail constructed by an extinct civilization, or a fragment of advanced technology that had wandered the galaxy for millions of years before chance brought it to our neighborhood. The hypothesis had been controversial, but it had also been rigorously scientific. Loeb had presented testable predictions, identified observational signatures that could confirm or refute his ideas, and maintained the intellectual humility that genuine scientific inquiry requires. The object had departed before definitive tests could be performed, leaving the question tantalizingly unresolved. Now, with 3-eye atlas displaying its own catalog of anomalies, patterns were beginning to emerge that suggested a broader phenomenon. 2 interstellar visitors, both exhibiting behaviors that challenged conventional understanding. 2 objects that seemed to carry within themselves the signature of processes more complex than simple gravitational accumulation in stellar nurseries. Dr. Kim, reviewing the comparative data late one evening in Harvard's astronomy library, found herself wondering whether humanity was witnessing the beginning of a new phase in its relationship with the cosmos. What if these aren't exceptions? She asked Loeb during one of their regular research meetings. What if they're representative of something larger, a population of interstellar objects that we are only now beginning to recognize? The question hung in the air between them, pregnant with implications that reached far beyond the boundaries of conventional astronomy. If objects like Oumuamua and 3-eye atlas were indeed part of a larger population of interstellar wanderers, each carrying complex chemistry and puzzling behaviors, then the galaxy might be far more dynamic and interconnected than anyone had previously imagined. Perhaps most intriguingly, both objects had approached our solar system during a period when human technology was finally sophisticated enough to detect and study them in detail. The timing seemed almost providential, as if the universe had waited until humanity was ready to receive these mysterious messengers from the depths of interstellar space. As 3-eye atlas continued its journey through the outer planets, still releasing its precious cargo of water vapor and organic compounds, researchers around the world began to prepare for the possibility that it would not be the last such visitor to challenge their understanding of what was possible in the cosmic dark. In the quiet hours before dawn, when the world balanced between night and day, and the most distant galaxies hung like dewdrops in the cosmic web, a profound recognition was beginning to crystallize in the minds of astronomers studying interstellar visitors. What had initially appeared to be isolated anomalies, strange objects exhibiting inexplicable behaviors, was revealing itself as something far more systematic and significant. The pattern emerged not all at once, but gradually, like a constellation becoming visible as eyes adjust to darkness. Oumuamua, with its mysterious accelerations and unusual light-reflecting properties. 2-eye Borisov, displaying chemical signatures that suggested formation in environments unlike our solar system. And now, 3I Atlas, gushing water vapor and complex organic molecules in patterns that defied conventional understanding of how frozen matter behaves in the interstellar medium. Dr. Chen, collaborating with research teams across 3 continents, began to construct a database that cataloged the anomalies exhibited by each confirmed interstellar visitor. The exercise revealed correlations that were both subtle and startling. Each object seemed to carry within itself evidence of processes that exceeded the random mixing and gravitational accumulation typically associated with primitive solar system formation. More intriguingly, the chemical inventories suggested that these objects might be sampling different regions of galactic chemistry. 2I Borisov had shown isotopic ratios consistent with formation near stars with unusual metallicity, perhaps in the galactic halo or in regions where stellar evolution had proceeded along pathways unknown in our local neighborhood. 3I Atlas carried organic compounds that hinted at complex chemistry occurring in environments with energy sources not found around typical main sequence stars. It was as if each interstellar visitor represented a different chapter in a vast cosmic story, a narrative written in the language of molecular bonds and isotopic ratios, telling of stellar deaths and births of chemical evolution occurring across vast scales of space and time. But perhaps most remarkable was the timing of their arrivals. In the brief span of human technological capability, the few decades during which our instruments had become sophisticated enough to detect and analyze such objects, 3 confirmed interstellar visitors had passed through our solar system. The statistical probability of such clustering suggested either extraordinary coincidence or the existence of a much larger population of interstellar objects than previously imagined. Loeb's team began to model the implications of this possibility. If interstellar space contained vast numbers of objects like Oumuamua, Borisov, and Atlas, then the galaxy was far more dynamic than conventional models suggested. Material might be flowing between star systems on a scale that could fundamentally alter understanding of how chemical complexity evolved in the cosmos. The concept was both humbling and exhilarating. Rather than existing as isolated islands of matter and energy, star systems might be connected by streams of chemical information, a vast network of molecular exchange that had been operating for billions of years, sharing the products of stellar nucleosynthesis and planetary formation across galactic distances. As the data from 3I Atlas continued to accumulate, painting an ever more detailed picture of its unusual properties, one question began to dominate discussions in research centers around the world. If these objects were indeed messengers carrying information between star systems, what story were they trying to tell? And perhaps more provocatively, what role might such objects play in the broader evolution of complexity and chemistry throughout the galaxy? The answers lay hidden in the patient analysis of light and shadow, in the careful measurement of molecular bonds forged in the depths of interstellar space, and in the gradual recognition that humanity might be witnessing something far grander than the random wandering of cosmic debris. In the sterile precision of computational laboratories where the fundamental laws of nature are tested against observational reality, a profound crisis was emerging from the 3I Atlas data. The mathematics were unforgiving in their clarity. The energy required to sustain the object's massive water vapor emissions simply didn't exist in any known physical process that could operate at such distances from the sun. Dr. Yuki Tanaka, a specialist in cometary physics at the University of Tokyo, had spent weeks running increasingly sophisticated models, each one designed to find some natural mechanism that could account for what they were observing. The numbers told a consistent story that defied comfortable explanation. Solar heating, the process that drives activity in conventional comets, delivered barely enough energy to 3I Atlas to warm its surface by a few degrees above absolute zero. Yet spectroscopic analysis showed water vapor streaming away from the object at rates that would require internal temperatures of several hundred degrees Kelvin, conditions that simply couldn't be maintained by such weak external heating. Radioactive decay offered another possibility, but the isotopic inventory of 3I Atlas showed no evidence of the heavy elements necessary to sustain significant energy generation through nuclear processes. The object appeared to be composed primarily of water ice and organic compounds, materials that are essentially inert in the absence of external energy sources. Chemical reactions presented a third avenue of investigation, but here too the physics proved uncooperative. While some exothermic reactions could theoretically generate heat within the object's interior, they would require initial activation energy that simply wasn't available in the frigid environment of deep space. Moreover, such reactions would quickly exhaust their reactants, leading to a rapid decline in activity, not the sustained, steady outflow that characterized 3I Atlas's behavior. As the weeks passed, and each potential explanation proved insufficient, researchers found themselves confronting an uncomfortable possibility. Either their understanding of fundamental physics was incomplete, or 3I Atlas was operating according to principles that hadn't yet been discovered or properly characterized. Dr. Martinez, working late into the Spanish night at the Instituto de Astrofísica de Canarias, discovered what might be the most puzzling aspect of the energy problem. Detailed thermal modeling showed that the object's core appeared to be maintaining a temperature gradient that was not only steep but also remarkably stable over time. "It's as if something inside is regulating the heat output," she confided to her research team during a video conference that connected laboratories across 4 continents. The implications were unsettling. Temperature regulation on such a scale suggested either chemical processes of extraordinary sophistication or physical mechanisms that operated outside the framework of conventional thermodynamics. In terrestrial environments, such regulation typically required biological systems of remarkable complexity, organisms that had evolved over millions of years to maintain internal conditions suitable for life. But 3I Atlas existed in the vacuum of interstellar space, where such complexity seemed impossible to achieve or maintain. The object's journey from its parent star system might have lasted millions or even billions of years, timescales that would defeat any biological system known to terrestrial science. Yet the data continued to accumulate, painting a picture of an object that somehow maintained internal processes of stunning complexity and precision. Each day brought new observations that challenged fundamental assumptions about what was possible in the realm between stars, forcing researchers to confront questions that reached to the very heart of how complexity and organization could emerge and persist in the cosmic environment. The physics problem was becoming something more than a scientific puzzle. It was evolving into a window through which humanity might glimpse possibilities that had never before been seriously considered. In the pre-dawn darkness of Chile's Atacama Desert, where the air is so thin and still that starlight reaches Earth, surface almost unfiltered by atmospheric interference, astronomers made a discovery that would transform understanding of what was possible in the heart of an interstellar visitor. Deep within the nucleus of 3I Atlas, something was glowing. The detection required the most sensitive instruments available to modern astronomy. Using adaptive optics to compensate for the tiny distortions caused by Earth's atmosphere, and employing integration times measured in hours rather than minutes, researchers were able to peer into the interior structure of the object with unprecedented resolution. What they found defied every model of how frozen matter should behave in the depths of space. Rather than the uniform, cold darkness expected in a primitive comet nucleus, spectroscopic analysis revealed regions of distinct thermal activity, zones where temperatures reached levels that could support complex chemical processes, even liquid water under pressure. Dr. Amanda Foster, leading the observational campaign from the European Southern Observatory, watched the data unfold on her monitors with a mixture of scientific excitement and profound unease. "We're looking at something that's not just warm inside," she explained to her international team of collaborators. "We're looking at something that appears to have structure, organized regions of different temperature and chemical activity. The thermal patterns weren't random. High-resolution imaging revealed what appeared to be a network of warmer channels threading through the object's interior, like a circulatory system designed to distribute heat and chemical products throughout the nucleus. These channels seemed to connect distinct zones of activity, creating an integrated system that maintained itself through processes that remained completely mysterious. Most remarkably, the internal glow showed wavelength signatures that suggested not just thermal emission, but active chemistry. Certain spectral lines indicated the presence of excited molecular states, compounds that had been energized beyond their ground state configurations. suggesting ongoing chemical reactions of considerable complexity and energy output. The discovery raised questions that reached to the foundations of astrobiology and planetary science. On Earth, such organized thermal and chemical activity typically occurred only in living systems, organisms that had evolved the biochemical machinery necessary to maintain complex internal processes in the face of environmental challenges. But 3I Atlas existed in conditions far more extreme than any terrestrial environment. The object had spent perhaps millions of years traveling through the interstellar medium, where temperatures approached absolute zero and radiation levels would sterilize any known biological system within hours or days. Yet here, in the heart of this ancient wanderer, something was maintaining processes that required not just energy, but organization, the systematic coordination of chemical reactions across spatial scales that suggested a level of complexity usually associated with life itself. Dr. Kim, analyzing the data from her laboratory at Harvard, found herself wondering whether the categories that human science used to understand matter and energy were adequate for describing what they were observing. Maybe the distinction between living and non-living isn't as clear-cut as we've assumed, she suggested during one of their team meetings. Maybe there are forms of organization that we haven't learned to recognize yet. As 3I Atlas continued its journey through the outer solar system, carrying within its core this mysterious internal light, astronomers around the world began to grapple with the possibility that they were witnessing something unprecedented in the history of science, a form of complexity that bridged the gap between inorganic chemistry and the organized processes typically associated with life. The implications were staggering, and they were only beginning to be understood. On a cold February morning in Cambridge, as snow fell gently on the historic brick buildings of Harvard University, Professor Avi Loeb sat in his office reviewing the complete dataset that had been gathered on 3I Atlas. The papers spread across his desk represented months of observations from dozens of telescopes around the world, each document adding another piece to a puzzle that challenged every assumption about natural processes in interstellar space. The evidence had accumulated with relentless logic: the impossible energy output, the organized internal structure, the complex chemistry proceeding at temperatures and pressures that shouldn't exist so far from any star, the systematic regulation of thermal processes across spatial scales that suggested coordination rather than random activity. Loeb had built his scientific reputation on intellectual courage, the willingness to follow evidence wherever it led, even when it challenged comfortable assumptions about the nature of reality. His work on Oumuamua had demonstrated his commitment to considering possibilities that other researchers dismissed as impossible or unscientific. But with 3I Atlas, the evidence was pointing toward conclusions that seemed to transcend even his previous willingness to challenge conventional wisdom. As he reviewed the thermal imaging data showing the object's internal structure, one possibility kept emerging from the analysis with mathematical inevitability. What if 3I Atlas wasn't entirely natural? The hypothesis wasn't born from science fiction speculation, but from the systematic elimination of conventional explanations. Every natural process that could theoretically account for the object's observed properties had been tested against the data and found insufficient. The energy budget didn't balance. The chemistry was too complex. The organization was too systematic. Dr. Kim joined him for their weekly research meeting, bringing with her the latest analysis from the international collaboration studying the object. "The internal structure is even more organized than we initially thought," she reported, spreading out thermal maps that revealed intricate patterns of temperature and chemical activity throughout the nucleus. Loeb studied the images with the careful attention of someone who understood that he might be looking at something unprecedented in human experience. The patterns weren't random. They showed signs of design, of purposeful arrangement that maximized efficiency in ways that natural processes rarely achieve. "Consider the possibility," he said, carefully choosing his words with the precision that rigorous science demands, "that we are looking at something that represents a form of engineering. Not necessarily the product of intelligence as we understand it, but perhaps the result of processes that transcend the random mixing and gravitational accumulation typical of primitive solar system formation." The idea was both radical and carefully constrained. Rather than claiming definitive knowledge about 3I Atlas's origins, Loeb was proposing a research framework that took seriously the possibility that interstellar space might contain objects whose organization exceeded what current scientific models could explain through purely natural processes. The engineering hypothesis didn't require conscious design or technological civilization. Throughout the cosmos, nature regularly produced structures of stunning complexity and organization, from the spiral architecture of galaxies to the intricate biochemistry of living cells. Perhaps the boundary between natural and artificial wasn't as clear-cut as human experience suggested, but 3I Atlas seemed to exist in a category of its own, too organized to be purely natural, yet too ancient and durable to be the product of technology as humans understood it. The object appeared to represent something intermediate, a form of organization that emerged from processes not yet understood by terrestrial science. As they continued their analysis through the winter months, Loeb's team began to develop a research program designed to test the engineering hypothesis through careful observation and theoretical modeling. The work would require extraordinary intellectual humility, the recognition that human understanding of what was possible in the universe might be far more limited than previously assumed. In the vast emptiness between stars, where matter exists in density so low that atoms might travel for centuries without encountering neighbors, an extraordinary possibility was beginning to emerge from the accumulated data on 3I Atlas. The object might not simply be wandering aimlessly through space. It might be engaged in something far more purposeful and profound. Dr. Elena Rodriguez, working late into the Madrid night at the Centro de Astrobiología, had been analyzing the chemical inventory being dispersed by 3I Atlas as it journeyed through the outer solar system. The water vapor was obvious, hundreds of kilograms streaming away from the nucleus every day, carrying with it the fundamental ingredients for planetary formation and biological chemistry. But it was the other compounds that captured her imagination and challenged her understanding of what interstellar objects might accomplish during their wanderings through the galaxy. Complex organic molecules, their carbon backbones arranged in patterns that suggested sophisticated chemical synthesis. Trace elements in ratios that seemed optimized for catalyzing the kinds of reactions that, in terrestrial environments, led to the emergence of increasing complexity and organization. Most intriguingly, isotopic analysis revealed that these compounds weren't simply the random products of stellar nucleosynthesis. They showed evidence of processing, of chemical pathways that had organized and concentrated specific elements in ways that enhanced their potential for participating in further reactions. It's as if 3I Atlas is carrying a seed bank, Rodriguez explained to her research team during one of their weekly meetings. Not biological seeds in the conventional sense, but chemical seeds, the precise molecular building blocks that could accelerate the formation of complex chemistry in any environment where conditions became suitable. The concept was both elegant and revolutionary. If objects like 3I Atlas regularly traverse the galaxy, dispersing optimized chemical inventories throughout interstellar space, then the universe might contain a vast network of chemical information exchange, a cosmic circulation system that shared the products of stellar evolution and chemical complexity across distances that would otherwise represent insurmountable barriers. The implications for planetary formation were staggering. Conventional models suggested that new solar systems began with relatively simple chemical inventories: hydrogen, helium, and trace amounts of heavier elements forged in previous generations of stars. But if interstellar visitors regularly deposited more complex materials into stellar nurseries, then planetary formation might proceed along pathways that were far more sophisticated and rapid than anyone had previously imagined. Dr. Thompson, collaborating from his laboratory at the University of Edinburgh, had been modeling the potential impact of such chemical seeding on the formation of planetary systems. His calculations suggested that even small amounts of organized organic matter could serve as catalysts that dramatically accelerated the processes by which simple compounds evolved into the complex chemistry necessary for life. "We might be witnessing a form of cosmic gardening," he suggested during one of their video conferences. "Objects like 3I Atlas could be the universe's way of planting chemical seeds that will bloom into new forms of complexity millions of years in the future." The seeding hypothesis offered a potential explanation for one of astrobiology's most persistent puzzles: how complex chemistry emerged so quickly after planetary formation in the early history of the solar system. If Earth and other worlds had been seeded with sophisticated organic compounds during their formation, then the rapid emergence of life became not just possible, but perhaps inevitable. As 3I Atlas continued its journey, still dispersing its precious chemical cargo throughout the solar system, researchers began to realize they might be witnessing something unprecedented: the real-time observation of cosmic seeding in action, the planting of chemical possibilities that might not bloom for millions of years but could ultimately transform the chemical evolution of our entire stellar neighborhood. In the grand cosmic theater where stars are born, live their brilliant lives, and die in spectacular displays of nuclear fire, a deeper pattern was beginning to emerge from the study of 3I Atlas, a pattern that suggested the universe might be far more interconnected and purposeful than humanity had ever dared to imagine. The story began billions of years ago in regions of space so distant that their light had not yet reached Earth, where massive stars burned through their nuclear fuel in a cosmic instant and exploded in supernovae that scattered the products of stellar nucleosynthesis across vast volumes of interstellar space. These stellar deaths, violent beyond human comprehension, became the foundation for new forms of complexity and beauty. Dr. James Morrison, a theoretical astrophysicist at Oxford University, had been developing models that traced the journey of matter from stellar death to planetary birth. Incorporating the new evidence provided by interstellar visitors like 3I Atlas, his calculations revealed a universe engaged in continuous recycling, a cosmic ecology where the death of one generation of stars provided the materials for increasingly sophisticated forms of organization in the next. Stars don't just die, he explained to his colleagues during a symposium on interstellar chemistry. They give birth to possibility. Every heavy element in our bodies, every molecule that makes life possible, was forged in the nuclear furnace of a dying star and scattered into space to become part of something new. But the evidence from 3I Atlas suggested that this recycling process was far more systematic and sophisticated than random stellar explosions could achieve alone. The object's organized chemistry, its optimized isotopic ratios, its systematic thermal regulation, all pointed toward processes that transcended simple gravitational accumulation in stellar nurseries. Perhaps, Morrison suggested, interstellar visitors like 3I Atlas represented a form of cosmic memory, objects that had somehow accumulated and preserved the chemical wisdom gained through billions of years of stellar evolution and planetary formation. Rather than allowing the products of complexity to disperse randomly through space, these objects might serve as vehicles for transporting organized matter and information between star systems. The implications were profound. If the universe contained mechanisms for preserving and transmitting chemical complexity across cosmic distances and timescales, then the evolution of matter from simple to complex wasn't just a local phenomenon occurring in isolated pockets of space. It was a universal process, a grand symphony of increasing organization that connected every star system to every other through invisible threads of chemical information. Dr. Sarah Chen, analyzing the latest spectroscopic data from 3I Atlas, found herself contemplating the philosophical dimensions of this possibility. Maybe consciousness isn't the endpoint of cosmic evolution, she mused during one of their team meetings. Maybe it's just one step in a process of increasing complexity that extends far beyond what we can currently imagine. The chemical compounds streaming away from 3I Atlas told a story that stretched across astronomical scales of space and time. Each molecule carried within its structure the memory of nuclear processes that had occurred in stars that died before our solar system was born. Each isotopic ratio preserved information about environments and pressures that had existed in the gravitational crucibles where heavy elements were forged. Yet this wasn't merely passive preservation. The organization visible in 3I Atlas's chemistry suggested active processes, mechanisms that selected, concentrated, and arranged matter in ways that enhanced its potential for participating in future episodes of cosmic evolution. As the object continued its journey through the outer planets, still releasing its cargo of chemical possibilities into the void, researchers began to recognize that they might be witnessing something unprecedented: the real-time operation of cosmic recycling systems that had been functioning for billions of years, quietly ensuring that the products of stellar death became the seeds of new forms of complexity and beauty. The universe, it seemed, was not just expanding and cooling toward ultimate entropy. It was actively engaged in the project of creating increasingly sophisticated forms of organization, and objects like 3I Atlas might be the messengers that made this cosmic recycling possible. As autumn deepened across the northern hemisphere, and 3I Atlas continued its inexorable journey through the outer reaches of the solar system, astronomers struggled to find adequate metaphors for describing what they were observing. The numbers were clear and unforgiving. The object was releasing approximately 40 kilograms of water vapor every second, a rate of emission so prodigious that it defied every model of how frozen matter should behave in the cosmic cold. Dr. Patricia Williams, observing from the Keck Observatory atop Mauna Kea, was among the first to coin the phrase that would capture public imagination. "It's like watching a fire hose running at full blast, except the hose is in deep space where nothing should be flowing at all." The metaphor was apt, but it barely conveyed the extraordinary nature of what was unfolding in the darkness between Mars and Jupiter. This wasn't the gentle, intermittent outgassing typical of comets beginning to warm as they approached the sun. This was a sustained, powerful outflow that spoke of internal processes operating with clockwork precision and inexhaustible energy reserves. High-resolution imaging revealed that the vapor wasn't escaping randomly from the object's surface. Instead, it emerged from specific locations, discrete vents or fissures that suggested underlying structure and organization. These emission points maintained consistent activity levels over weeks and months, displaying a stability that natural geological processes rarely achieve. Most remarkably, the chemical composition of the outflow remained remarkably constant, despite the massive quantities being released. Spectroscopic analysis showed that the water vapor maintained consistent isotopic ratios and trace element concentrations, as if the object possessed internal mechanisms for regulating the chemistry of its emissions. Dr. Kim, analyzing the data from Harvard, found herself wondering about the implications of such systematic behavior. "If this were a terrestrial system," she observed during one of their research meetings, "we'd be looking at evidence of sophisticated regulatory mechanisms. Biological or technological systems capable of maintaining homeostasis in the face of massive material loss." But 3I Atlas existed in an environment where such mechanisms seemed impossible to achieve or maintain. The object had likely spent millions of years traveling through interstellar space, where temperatures approached absolute zero, and radiation would sterilize any known biological system within hours or days. Yet here was evidence of regulation, of systematic control over physical and chemical processes that extended across the entire nucleus of the object. The fire hose effect wasn't random. It was controlled, purposeful, as if something within 3I Atlas was managing the release of its chemical cargo, according to principles that remained completely mysterious to human science. The energy requirements for sustaining such massive outflow were staggering. Every kilogram of water vapor that escaped into space carried with it not just matter, but thermal energy, heat that had somehow been generated within the object's core and transported to the surface with remarkable efficiency. Thermal modeling suggested that maintaining the observed outflow rates would require internal temperatures of several hundred degrees Kelvin, conditions that could support not just the vaporization of ice, but complex chemical reactions and even, under pressure, liquid water systems. As the weeks passed and the fire hose effect continued with undiminished intensity, researchers began to realize they were witnessing something unprecedented in the annals of astronomy. This wasn't simply unusual behavior. It was systematic, controlled activity that suggested forms of organization that transcended conventional understanding of what was possible in interstellar objects. The implications reached far beyond the boundaries of cometary science, challenging fundamental assumptions about the nature of matter, energy, and organization in the cosmic environment, and raising questions that would require entirely new theoretical frameworks to address adequately. In the rust-colored desolation of the Martian landscape, where ancient riverbeds carved their stories into stone and polar ice caps marked the passage of countless seasons, humanity's most sophisticated interplanetary probe maintained its silent vigil over the solar system's most enigmatic visitor. The European Space Agency's trace gas orbiter, designed to study the thin Martian atmosphere and search for signs of past or present life, had been redirected to observe 3I Atlas as the mysterious object passed within optimal viewing range of the red planet. The spacecraft's advanced spectrometers and imaging systems provided an unprecedented close-up view of the interstellar visitor's activity. From Mars's unique vantage point, the trace gas orbiter captured images that would become iconic in the annals of space exploration. 3I Atlas appeared as a brilliant emerald jewel against the star-filled backdrop of deep space, its nucleus surrounded by vast gossamer streams of vapor that caught and scattered sunlight in patterns of ethereal beauty. But it was the detail visible in these images that truly captured the attention of researchers around the world. The vapor streams weren't uniform clouds. They showed structure, organization, patterns that suggested underlying processes far more complex than simple sublimation of surface ice. Dr. Alessandro Rossi, leading the observational campaign from the European Space Operations Center in Darmstadt, found himself studying images that challenged everything he thought he knew about cometary behavior. We're seeing discrete jets, multiple emission points, and what appears to be systematic variation in the intensity and chemical composition of different outflow streams, he reported to the international research team. The high-resolution data revealed that 3I Atlas wasn't simply leaking vapor into space. It was actively ejecting material through what appeared to be a network of organized channels or vents. These emission points maintained distinct chemical signatures, as if different regions of the object's interior were contributing different components to the overall outflow. Most remarkably, the trace gas orbiter detected temporal variations in the emission patterns that seemed to follow regular cycles. Rather than the random fluctuations expected from natural sublimation processes, the object displayed periodicities that suggested internal timing mechanisms of extraordinary precision. The symbolic juxtaposition wasn't lost on researchers studying the data. Here was Mars, a world that had once possessed flowing water and might have harbored life billions of years ago, serving as a silent witness to the passage of an object that carried within itself the chemical building blocks for new forms of complexity and organization. The planet's thin atmosphere, composed primarily of carbon dioxide with traces of water vapor and other compounds, provided an ideal observational environment for studying 3I Atlas's emissions. The lack of atmospheric interference allowed the trace gas orbiter's instruments to detect molecular signatures that would have been impossible to observe from Earth-based telescopes. As the images and data streamed back to Earth across the vast gulf of interplanetary space, researchers began to piece together a picture of 3I Atlas that transcended their wildest expectations. This wasn't simply a chunk of ice and rock wandering through space. It was a complex, organized system that maintained sophisticated internal processes while journeying between the stars. The red planet watched in silence as the Emerald visitor continued its cosmic odyssey, carrying with it secrets that might illuminate fundamental questions about the nature of complexity, organization, and perhaps even life itself in the vast theater of interstellar space. The observations from Mars would prove to be crucial in developing new theoretical frameworks for understanding not just 3I Atlas, but the broader population of interstellar objects that might be traversing the galaxy, carrying chemical information and organizational complexity across distances that would otherwise represent insurmountable barriers to the exchange of matter and information between star systems. In the theoretical physics laboratories, where the fundamental processes of cosmic evolution are modeled through elegant mathematics and computational simulations, a revolutionary idea was crystallizing around the accumulated evidence from 3I Atlas. The object might not simply be wandering aimlessly through space. It might be engaged in something far more profound and purposeful: the systematic construction of new planetary systems. Dr. Rachel Martinez, working late into the Spanish night at the Instituto de Astrofísica de Andalucía, had been developing models that incorporated the chemical seeding hypothesis into broader theories of planetary formation. Her calculations suggested possibilities that were both elegant and revolutionary, challenging fundamental assumptions about how worlds come into being. Traditional models of planetary formation depicted a relatively slow, chaotic process. Dust grains collided and stuck together through electrostatic forces, gradually accumulating into pebbles, then rocks, then planetesimals, and finally planets. The process required millions of years and was notoriously inefficient, with most material scattered or ejected from developing systems rather than incorporated into stable worlds. But what if objects like 3I Atlas served as catalysts that could dramatically accelerate and optimize this process? The chemical inventory being dispersed by the interstellar visitor wasn't random. It was organized, concentrated, and precisely tuned to enhance the kinds of reactions that led to increasing complexity and organization. Consider the possibility, Martinez explained to her international research team during a video conference that connected laboratories across 4 continents, that we're witnessing a form of cosmic engineering, not conscious design necessarily, but systematic processes that overcome the natural barriers to planetary formation. The theory was supported by mounting evidence from the 3I Atlas observations. The object's sustained outflow of water vapor and organic compounds was dispersing throughout the solar system at precisely the time when several of the outer planets were experiencing seasonal changes that created optimal conditions for chemical processing and atmospheric circulation. Jupiter's complex magnetosphere was capturing and concentrating some of the dispersed material, creating enhanced auroral activity that drove chemical reactions in the planet's upper atmosphere. Saturn's ring system was incorporating microscopic particles from the 3I Atlas outflow, potentially altering the dynamics of ring evolution and moon formation around the gas giant. Most intriguingly, long-term tracking of the dispersed material suggested that significant quantities were being gravitationally focused toward regions of the solar system where new objects might eventually condense from the accumulated matter. The process was subtle, operating over timescales measured in millions of years, but the mathematical models indicated clear trends toward enhanced accretion in specific orbital zones. Dr. Thompson, analyzing the data from Edinburgh, had developed simulations showing how chemical seeding by interstellar visitors could fundamentally alter the timeline and efficiency of planetary formation. Instead of requiring hundreds of millions of years for worlds to develop complex chemistry, he explained, seeded systems might achieve the same level of organization in just tens of millions of years. The implications were staggering. If the galaxy contained vast populations of interstellar objects like 3I Atlas, each carrying optimized chemical inventories between star systems, then planetary formation might be far more systematic and rapid than anyone had previously imagined. Rather than isolated episodes of accretion occurring independently in stellar nurseries, world building might be a coordinated, galaxy-wide process that shared information and materials across astronomical distances. The Planet Maker theory offered potential solutions to several persistent puzzles in planetary science: the rapid development of complex chemistry in early Earth history, the systematic spacing of planetary orbits, the mysterious abundance of water and organic compounds in outer solar system objects. Each observation of 3I Atlas added new dimensions to this emerging understanding, suggesting that humanity might be witnessing something unprecedented: the real-time operation of cosmic systems that had been constructing worlds for billions of years, quietly ensuring that the products of stellar death became the seeds of new forms of complexity and beauty throughout the galaxy. In the infinite cathedral of space, where galaxies spiral through darkness like islands of light, separated by gulfs of emptiness so vast that light itself grows weary crossing them, a profound perspective was beginning to emerge from humanity's encounter with 3I Atlas. The object was more than an anomaly. It was a window into processes that operated on scales almost too grand for human comprehension. Picture the Milky Way as seen from impossible distance, its spiral arms rotating with stately grace through cosmic time, each arm containing hundreds of billions of stars, each star potentially nurturing worlds, each world representing countless opportunities for matter to organize itself into forms of ever-increasing complexity and beauty. From this cosmic perspective, the journey of 3I Atlas took on dimensions that transcended its immediate mystery. The object wasn't simply traveling from one star system to another. It was participating in a grand circulation system that connected every corner of the galaxy, carrying chemical information and organizational templates across distances that would otherwise represent insurmountable barriers to the flow of complexity. Dr. Morrison, contemplating these implications from his office at Oxford, found himself developing models that depicted the galaxy not as a collection of isolated star systems, but as a single integrated ecosystem, a cosmic organism in which interstellar objects like 3I Atlas served as circulation cells, ensuring that the products of stellar evolution and planetary formation were shared across astronomical distances. "We've been thinking too locally," he explained to his colleagues during a symposium on galactic evolution. "Star systems aren't isolated islands. They're connected by streams of matter and information that we're only now beginning to recognize and understand." The mathematical models painted a picture of stunning coordination. Interstellar objects following trajectories that seemed random from limited human perspective revealed themselves, when viewed across galactic timescales, to be following systematic patterns that optimize the distribution of chemical complexity throughout stellar neighborhoods. Some objects, like 3I Atlas, might be carrying the products of stellar nucleosynthesis from older metal-rich regions of the galaxy to younger star-forming areas where heavy elements remained scarce. Others might be transporting the chemical signatures of planetary formation from systems where world-building had proceeded successfully to regions where conditions were just becoming suitable for similar processes. The traffic was not random. It was regulated by the same gravitational and magnetic forces that shaped the galaxy's large-scale structure. Spiral density waves compressed interstellar matter and accelerated the exchange of materials between different galactic regions. The galaxy's magnetic field, threading through space like invisible highways, guided the paths of charged particles and influenced the trajectories of objects carrying significant electromagnetic signatures. From this expanded perspective, 3I Atlas wasn't an alien visitor. It was a native of the galaxy, a participating member of cosmic ecosystems that had been operating for billions of years before Earth formed and would continue operating for billions of years after the Sun exhausted its nuclear fuel and faded to a cooling white dwarf. The implications reached beyond astronomy into philosophy and theology. If the galaxy truly operated as an integrated system for generating and distributing complexity, then consciousness itself might not be an accident or aberration, but a natural and perhaps inevitable consequence of cosmic evolution, one link in a chain of increasing organization that connected the birth of matter in the Big Bang to possibilities that humanity couldn't yet imagine. As 3I Atlas continued its journey through the outer solar system, still releasing its cargo of chemical possibilities into the void, researchers began to realize they were witnessing something unprecedented: the real-time operation of galactic circulation systems that challenged every assumption about isolation, randomness, and the fundamental nature of cosmic evolution. The universe, it seemed, was far more intentional than anyone had dared to hope. In the hallowed halls of scientific institutions around the world, where peer review serves as the guardian of empirical truth and skepticism, functions as the immune system of human knowledge, a necessary counterpoint was emerging to the increasingly bold theories surrounding 3I Atlas. The conservative voice of mainstream astronomy, speaking through researchers who had built their careers on careful observation and methodical analysis, offered a sobering perspective on the extraordinary claims being made about the interstellar visitor. Dr. Robert Chang, a veteran astronomer at the California Institute of Technology, who had spent 3 decades studying comets and asteroids, represented this cautious approach to the 3I Atlas mystery. His decades of experience had taught him that nature was often more subtle and complex than initial observations suggested, but also that extraordinary claims required extraordinary evidence. "We must be careful not to let our imagination run ahead of our data," Chang cautioned during a symposium on interstellar objects at the American Astronomical Society meeting. Every generation of astronomers has faced phenomena that seem to defy explanation, only to find that natural processes, perhaps exotic ones but natural nonetheless, could account for what they were observing. The skeptical perspective didn't dismiss the unusual properties of 3I Atlas, but it approached them with the methodical patience that had served science well for centuries. The object's massive water vapor emissions might be explained by previously unknown forms of sublimation, perhaps triggered by chemical reactions between surface minerals and trace amounts of solar radiation, or by internal heating from the decay of radioactive isotopes that hadn't yet been detected. The organized internal structure visible in thermal imaging could result from differential sublimation rates in materials of varying composition and density. Comets were known to be dirty snowballs, with complex internal architecture resulting from their formation in the chaotic environments of stellar nurseries. Perhaps 3I Atlas simply represented an extreme example of such complexity, rather than evidence of processes that transcended natural explanations. Dr. Susan Fletcher, studying the object from the Jet Propulsion Laboratory, had developed models that showed how gravitational interactions with massive planets during the object's journey through interstellar space could have compressed and organized its internal structure in ways that might account for the observed thermal and chemical activity. We shouldn't underestimate the sophistication of natural processes, Fletcher argued during one of the many scientific debates that 3I Atlas had sparked. The universe has had billions of years to develop mechanisms that might seem impossible or artificial from our limited perspective, but which operate according to physical laws we simply haven't fully understood yet. The skeptical position served a crucial function in the scientific ecosystem surrounding 3I Atlas. It ensured that alternative explanations received careful consideration, that observational claims were subjected to rigorous verification, and that the extraordinary implications being drawn from the data were tested against the highest standards of empirical evidence. But even the most conservative researchers acknowledged that 3I Atlas presented challenges to conventional understanding. The energy budget remained problematic. The systematic nature of the object's behavior was difficult to explain through random processes alone. The chemical organization visible in its emissions suggested levels of complexity that pushed against the boundaries of what natural selection might achieve in non-biological systems. Dr. Chang, despite his cautious approach, admitted during private conversations with colleagues that 3I Atlas might represent a form of cosmic phenomenon that didn't fit neatly into existing categories. Perhaps the question isn't whether this object is natural or artificial, he suggested, but whether our current understanding of what's natural is sophisticated enough to encompass the full range of possibilities that the universe might contain. This nuanced skepticism, questioning extraordinary claims while remaining open to extraordinary possibilities, represented the scientific method at its finest, ensuring that humanity's encounter with 3I Atlas would advance knowledge rather than merely confirming pre-existing beliefs or fears. In the quiet moments before dawn, when the boundaries between night and day blur into uncertainty, and the mind is most receptive to possibilities that daylight logic might dismiss, even the most conservative astronomers studying 3I Atlas found themselves confronting an uncomfortable truth. The standard models that had served science well for decades were proving inadequate for describing what they were observing. Dr. Chang, whose skeptical voice had provided necessary counterpoint to the more speculative theories surrounding the interstellar visitor, sat in his office at Caltech reviewing the complete dataset that had accumulated over months of observation. The numbers were clear, unambiguous, and deeply troubling for anyone committed to conventional explanations of cometary behavior. The energy calculations remained stubbornly problematic. Every attempt to model the object's massive vapor emissions through natural heating mechanisms fell short by orders of magnitude. Solar radiation at 3I Atlas, its distance from the sun, could barely warm its surface above the background temperature of interstellar space, yet the object was somehow sustaining internal processes that required temperatures hundreds of degrees higher. Radioactive decay offered another possibility, but spectroscopic analysis showed no evidence of the heavy isotopes necessary to generate significant amounts of heat through nuclear processes. The object appeared to be composed primarily of water ice and complex organic compounds, materials that should remain essentially inert in the absence of external energy sources. Chemical reactions provided a third avenue for investigation, but here too the physics proved uncooperative. While some exothermic reactions could theoretically release heat within the object's interior, they would require activation energies that simply weren't available in the frigid environment of deep space. Moreover, such reactions would quickly consume their reactants, leading to rapidly declining activity rather than the sustained, steady outflow that characterized 3I Atlas's behavior. Dr. Fletcher, whose career had been built on developing increasingly sophisticated models of cometary physics, found herself staring at computer simulations that consistently failed to reproduce the observed properties of the interstellar visitor. "We're missing something fundamental," she confided to her research team during one of their weekly meetings. "Either our understanding of basic physics is incomplete, or we're dealing with processes that operate outside the framework of conventional thermodynamics." The systematic nature of 3I Atlas's behavior presented perhaps the greatest challenge to natural explanations. The object's thermal regulation, its organized chemical emissions, its precisely controlled vapor outflow, all suggested levels of coordination that were difficult to achieve through random processes alone. On Earth, such systematic behavior typically required biological organisms that had evolved complex regulatory mechanisms over millions of years, or technological systems designed by intelligent agents capable of understanding and manipulating physical processes. But 3I Atlas existed in the vacuum of interstellar space where biological systems seemed impossible, and technological explanations challenged fundamental assumptions about the distribution of intelligence in the universe. Yet the data continued to accumulate, painting an ever more detailed picture of an object that seemed to exist at the boundary between the natural and the artificial, between the random and the systematic, between the simple and the impossibly complex. Some researchers began to wonder whether the categories that human science used to understand matter and energy were adequate for describing phenomena that might emerge from billions of years of cosmic evolution. Perhaps there were forms of organization that transcended the conventional boundaries between living and non-living systems, forms of complexity that could emerge and persist in environments far more extreme than any terrestrial analog. The possibility was both humbling and exhilarating. It suggested that the universe might contain depths of sophistication and organization that humanity was only beginning to glimpse, processes that operated according to principles not yet discovered or properly understood by terrestrial science. As 3I Atlas continued its journey through the outer solar system, still defying every attempt to fit it into conventional categories, researchers around the world began to recognize that they might be witnessing something unprecedented, a phenomenon that required entirely new theoretical frameworks, new ways of thinking about what was possible in the vast theater of cosmic evolution. In the profound silence that exists between heartbeats, between thoughts, between the tick of one moment and the birth of the next, the implications of 3I Atlas began to reveal themselves not as external mysteries to be solved, but as reflections of humanity's own place in the vast cosmic story that was still being written among the stars. Dr. Sarah Chen, working alone in her laboratory as snow fell gently outside the windows of the Harvard-Smithsonian Center for Astrophysics, found herself contemplating questions that reached far beyond the boundaries of conventional astronomy. If objects like 3I Atlas truly served as carriers of chemical complexity between star systems, what did that suggest about the nature of life itself? What did it mean for humanity's understanding of its own origins and destiny? The carbon atoms in her body had been forged in the nuclear furnaces of ancient stars that died billions of years before the sun was born. The oxygen she breathed had been scattered into space by stellar explosions so violent, they briefly outshone entire galaxies. The water in her cells had condensed from vapor clouds in the cold depths of interstellar space, perhaps carried by objects not unlike 3I Atlas on journeys that spanned millions of years. In this sense, every human being was already a participant in the cosmic circulation system that 3I Atlas represented. Every living thing on Earth had been assembled from materials that had traveled unimaginable distances through space and time, carrying within their atomic structure the memory of stellar births and deaths of chemical processes that had unfolded in environments Earthborn life could never directly experience. But 3I Atlas suggested something more profound than mere chemical recycling. The object's organized complexity, its systematic behavior, its apparent role in seeding new environments with the building blocks of further organization, all pointed toward a universe that was actively engaged in the project of creating and distributing ever more sophisticated forms of complexity. If this interpretation was correct, then consciousness itself might not be an accident or aberration, but a natural and perhaps inevitable consequence of cosmic evolution. Human awareness, with its capacity for wonder, curiosity, and understanding, might represent one step in a vast process of increasing organization that connected the Big Bang to possibilities that couldn't yet be imagined. The idea was both humbling and empowering. It suggested that humanity's drive to explore, to understand, to create meaning from the apparent chaos of existence, was itself a continuation of cosmic processes that had been operating for billions of years. The same forces that guided 3I Atlas on its interstellar journey might be expressing themselves through human consciousness, through the scientific quest to understand the nature of reality itself. Dr. Kim, joining Chen for one of their late-night discussions that had become a tradition during the months of 3I Atlas observation, raised the question that had been haunting both of them. If we're part of this cosmic circulation system, if consciousness is one way the universe develops complexity and understanding, then what's our responsibility? What role are we supposed to play in this vast process? The question hung in the air between them, pregnant with implications that reached far beyond the realm of astronomy. If humanity was indeed part of a cosmic ecosystem dedicated to creating and distributing complexity, then perhaps the species' destiny lay not just in exploring and understanding the universe, but in actively participating in its evolution. The space program, the search for extraterrestrial intelligence, the development of technologies that could eventually carry human consciousness to other star systems, all of these endeavors might represent natural expressions of cosmic evolution, ways in which the universe was preparing to spread awareness and understanding across galactic distances. As 3 Atlas continued its journey through the darkness, still releasing its cargo of chemical possibilities into the void, it served as a mirror that reflected humanity's own cosmic significance, challenging the species to see itself not as isolated observers of cosmic processes, but as active participants in the universe's ongoing project of creation and discovery. As winter deepened across the northern hemisphere, and 3I Atlas approached the outer boundary of the solar system, its gravitational influence, the ethereal streams of vapor that had first captured humanity, his attention began to take on symbolic dimensions that transcended their immediate scientific significance. Each droplet of water that escaped into the void carried within itself a message written in the universal language of chemistry, a communication that spoke not through words or signals, but through the patient offering of possibility itself. The spectroscopic analysis had revealed the profound generosity embedded in this cosmic visitor. The water vapor wasn't simply waste material being discarded as 3I Atlas journeyed through space. It was precisely the substance that made complex chemistry and life possible throughout the universe. Hydrogen and oxygen, combining in perfect proportion to create the solvent in which all known biological processes unfolded. But the gift extended far beyond mere H2O. Embedded within the vapor streams were trace compounds of extraordinary sophistication, organic molecules that had somehow been preserved and concentrated during the object's long journey through interstellar space. These weren't random chemical debris, but organized assemblies of carbon, nitrogen, phosphorus, and sulfur arranged in patterns that enhanced their potential for participating in the kinds of reactions that, in terrestrial environments, led to the emergence of life itself. Dr. Elena Rodriguez, analyzing the chemical inventory from her laboratory in Madrid, found herself moved by the elegance of what she was observing. "It's as if 3I Atlas is making an offering," she told her research team during one of their weekly meetings. Not just sharing its substance, but sharing the very building blocks of complexity and organization. The timing of this offering seemed almost providential. 3I Atlas had arrived during a period when humanity's technological capabilities were finally sophisticated enough to detect and analyze its chemical gifts in detail. Earlier generations of astronomers might have observed the object's unusual brightness and motion, but they would have lacked the spectroscopic tools necessary to decode the molecular messages embedded in its vapor streams. The dispersal pattern was equally remarkable. Rather than releasing its chemical cargo randomly into space, 3I Atlas seemed to be distributing materials in patterns that optimized their potential for future encounters with planetary systems. Gravitational modeling suggested that significant quantities of the dispersed matter would eventually be incorporated into the Kuiper Belt and Oort cloud, where they could remain preserved for millions of years before being disturbed by future cometary visitors or gravitational perturbations. Some of the material was being carried by solar wind toward the inner planets, where it would eventually be captured by Earth's magnetosphere and incorporated into the planet's upper atmosphere. The quantities were tiny by terrestrial standards, but the chemical complexity was unprecedented, each molecule representing a form of information that could potentially catalyze new forms of organization in whatever environment it eventually encountered. The symbolic dimensions of this process weren't lost on researchers studying the phenomenon. Here was an object that had traveled perhaps millions of years through the loneliness of interstellar space, carrying within itself the chemical wisdom of distant stellar environments, only to arrive at humanity's doorstep, precisely when the species was beginning to search for signs of life and complexity beyond Earth. The message embedded in the mist wasn't a communication in any conventional sense. It contained no encoded information, no attempt at symbolic representation. Instead, it was a gift that spoke through action rather than words. The patient sharing of the fundamental materials from which complexity, organization, and perhaps consciousness itself could emerge. As the vapor streams continued to catch and scatter sunlight in patterns of ethereal beauty, creating temporary auroras in the thin atmospheres of the outer planets, humanity found itself the recipient of a cosmic inheritance that had been traveling the galaxy for eons, waiting for the moment when it could fulfill its purpose by contributing to the next phase of cosmic evolution. In the comfortable quietude of his Harvard office, where afternoon light filtered through windows that had witnessed decades of scientific contemplation, Professor Avi Loeb sat surrounded by the accumulated data, theories, and implications that 3I Atlas had brought into humanity's awareness. The papers spread across his desk represented more than mere scientific observations. They documented a transformation in how human consciousness might understand its place in the cosmic order. Loeb had built his reputation on intellectual courage, on the willingness to follow evidence wherever it led, even when it challenged comfortable assumptions about the nature of reality. His career had been marked by theoretical breakthroughs that emerged from asking questions others considered too speculative or dangerous to pursue seriously. But 3I Atlas had presented him with something different. Not just an opportunity to develop new theories, but a profound responsibility to help humanity grapple with implications that reached far beyond the boundaries of academic astronomy. Science, he reflected during a recorded interview that would become part of the historical record surrounding humanity, his encounter with the interstellar visitor, is ultimately about maintaining childlike curiosity in the face of the unknown. It requires the humility to acknowledge that our current understanding might be incomplete, and the courage to explore possibilities that challenge our preconceptions. The months of studying 3I Atlas had reinforced Loeb's conviction that the universe was far stranger and more wonderful than mainstream scientific conservatism typically acknowledged. The object's systematic behavior, its organized complexity, its apparent role in cosmic circulation systems, all pointed toward forms of organization that transcended the random processes typically invoked to explain natural phenomena. Yet Loeb was careful to frame his interpretation within the rigorous methodology that genuine scientific inquiry required. Rather than claiming certainty about 3I Atlas's ultimate nature or origins, he focused on developing testable hypotheses that could guide future observations and theoretical work. The question isn't whether we have all the answers, he explained to colleagues who sometimes criticized his willingness to consider unconventional possibilities. The question is whether we're asking the right questions, questions that honor both the evidence we're observing and the vast scope of what we don't yet understand. The implications of the 3I Atlas phenomenon extended far beyond astronomy into philosophy, theology, and humanity's understanding of its cosmic significance. If objects like this interstellar visitor truly served as carriers of complexity between star systems, then consciousness itself might represent a natural expression of cosmic evolution rather than an isolated accident on a single planet. This possibility filled Loeb with both wonder and responsibility. If humanity was indeed part of a vast cosmic ecosystem dedicated to creating and distributing complexity, then the species bore an obligation to participate constructively in that process. The search for extraterrestrial intelligence, the development of space exploration capabilities, the cultivation of scientific understanding, all of these endeavors might represent natural expressions of humanity's role in cosmic evolution. But Loeb was equally aware of the dangers inherent in such profound implications. Throughout history, Humans had often been too quick to assume cosmic significance, to interpret natural phenomena as confirmation of pre-existing beliefs or desires. The scientific method existed precisely to guard against such tendencies, ensuring that extraordinary claims were supported by extraordinary evidence. "We must maintain a delicate balance," he observed during one of his seminars on interstellar objects, "between openness to revolutionary possibilities and commitment to rigorous empirical standards. The universe is under no obligation to conform to our expectations, but neither are we obligated to accept claims that aren't supported by careful observation and analysis." As 3I Atlas continued its journey beyond the solar system's gravitational boundary, carrying with it secrets that might never be fully decoded, Loeb found himself grateful for the opportunity to participate in humanity's encounter with genuine cosmic mystery, an encounter that reminded him why he had devoted his life to the patient pursuit of understanding in the face of infinite wonder. In the vast cathedral of space where 3I Atlas now journeyed beyond the gravitational embrace of humanity, his solar system, a profound stillness settled over the cosmic theater that had witnessed months of unprecedented scientific drama. The interstellar visitor, having shared its chemical gifts with the planets and moons it encountered during its passage, now returned to the eternal silence that exists between stellar neighborhoods, a silence so complete that it transforms sound itself into an impossible concept. Here, in the realm where distances were measured not in kilometers but in light years, where the nearest star appeared as nothing more than a bright point among countless others, the true scale of 3I Atlas's journey began to reveal itself. The object had already traveled farther from its unknown point of origin than humanity had ever sent its most ambitious space probes. Yet for an interstellar visitor, this distance represented merely the beginning of a voyage that might continue for millions of years before gravitational chance brought it within the influence of another star system. The silence that surrounded 3I Atlas was not empty. It was pregnant with possibility. Each cubic meter of interstellar space contained atoms of hydrogen and helium, traces of heavier elements forged in stellar nucleosynthesis, cosmic rays carrying the memory of distant supernovae, and magnetic fields that connected star systems across galactic distances. But these components existed in such extreme dilution that vast regions of space contained less matter than the best laboratory vacuums achievable on Earth. In this environment, the continued activity within 3I Atlas took on dimensions that challenged fundamental assumptions about what was possible in the cosmic void. The object's internal processes, whatever their ultimate nature, had somehow sustained themselves through conditions that would defeat any known biological or technological system within hours or days. Dr. Chen, contemplating the implications from her laboratory at Harvard, found herself wondering about the subjective experience of such a journey, if subjective experience was even a meaningful concept for an object like 3I Atlas. What would it mean to maintain organized complexity while traveling through regions of space so empty that encounters with individual atoms might be separated by years or decades? The question touched on philosophical dimensions that reached beyond the boundaries of conventional science. If 3I Atlas truly represented a form of cosmic organization that transcended the categories typically used to understand matter and energy, then perhaps it also transcended the conventional boundaries between consciousness and unconsciousness, between experience and mere existence. The silence between stars had witnessed countless such journeys over the billions of years since galaxies first formed and began launching their chemical products into the interstellar medium. Objects like 3I Atlas might represent a form of cosmic circulation that had been operating since the earliest epochs of cosmic evolution, quietly ensuring that the products of stellar nucleosynthesis and planetary formation were shared across distances that would otherwise represent insurmountable barriers to the flow of complexity. As the data streams from Earth's telescopes gradually lost their ability to detect 3I Atlas against the background noise of deep space, researchers began to grapple with the profound loneliness of the object's continued journey. Unlike human space probes, which maintained radio contact with their creators and carried messages intended for potential discovery by alien civilizations, 3I Atlas traveled in complete isolation, guided only by the gravitational choreography of stellar motion and the mysterious internal processes that had sustained it through eons of interstellar wandering. Yet perhaps this isolation was itself meaningful. The silence between stars might represent not emptiness but potential, a cosmic meditation space where matter and energy could organize themselves according to principles that crowded, active environments couldn't support. In the infinite patience of interstellar travel, complexity might achieve forms of organization impossible in the gravitational chaos of stellar neighborhoods. The thought offered a new perspective on humanity's place in cosmic evolution. Rather than existing as isolated observers of cosmic processes, humans might be participants in a vast conversation conducted in the language of chemistry and consciousness, a conversation that unfolded across galactic distances and cosmic timescales, connecting every form of awareness to every other through invisible threads of mutual recognition and shared purpose. As 3I Atlas faded beyond the reach of humanity's most powerful telescopes, becoming once again just another point of light indistinguishable from the stellar background, the scientific community found itself transformed by the encounter. The months of observation and analysis had not merely added another entry to the catalog of known interstellar objects. They had opened a window into possibilities that would reshape astronomy, astrobiology, and humanity's understanding of its place in the cosmic order for generations to come. In laboratories and observatories around the world, new research programs were already taking shape based on the insights gleaned from 3I Atlas. Advanced space missions were being designed to intercept future interstellar visitors before they could disappear back into the cosmic deep. Theoretical frameworks were being developed to model the complex chemistry and organized behavior that such objects might exhibit. International collaborations were forming to coordinate the search for additional members of what scientists were beginning to recognize as a previously unknown population of cosmic wanderers. Dr. Sarah Kim, working late into the Massachusetts winter night, was developing proposals for space-based observatories specifically designed to detect and study interstellar objects during their brief passages through the solar system. The technology existed to launch sophisticated probes that could rendezvous with future visitors, collecting direct samples of their chemical inventory, and perhaps even landing on their surfaces to study their internal structure and processes. 3I Atlas was just the beginning, she explained to a gathering of space agency officials and private aerospace entrepreneurs. We now know that interstellar space contains objects of extraordinary complexity and potential scientific significance. The question is not whether we'll encounter more of them, it's whether we'll be ready to take full advantage of those encounters when they occur. The European Space Agency was already developing plans for an ambitious mission called Interstellar Interceptor, designed to position a fleet of sophisticated probes in the outer solar system, where they could respond quickly to the detection of new interstellar visitors. The probes would carry advanced spectrometers, sample collection systems, and communication equipment capable of transmitting detailed data back to Earth, even as they traveled alongside their targets into the depths of interstellar space. NASA's Jet Propulsion Laboratory was working on complementary technologies that could analyze the internal structure of interstellar objects using penetrating radar and seismic monitoring systems. These instruments might finally answer the fundamental questions about how such objects maintained their complex internal processes during millions of years of travel through the cosmic void. But perhaps the most ambitious project emerging from the 3I Atlas encounter was the Galactic Chemistry Survey, an international effort to map the distribution and flow of complex organic compounds throughout the local region of the galaxy. By studying the chemical signatures of interstellar objects, stellar nurseries, and planetary systems, researchers hope to trace the pathways by which complexity and organization spread through cosmic space and time. The implications of such research extended far beyond pure science. If interstellar objects truly served as carriers of chemical complexity between star systems, then understanding their population and behavior might provide crucial insights into the likelihood of life emerging elsewhere in the galaxy. Planets that had been seeded with sophisticated organic compounds might develop complex chemistry, and perhaps life itself, far more rapidly than worlds that had to build complexity from simple stellar debris alone. Dr. Loeb, contemplating these possibilities from his Harvard office, found himself both humbled and exhilarated by the prospects that 3I Atlas had revealed. "We're standing at the threshold of a new era in cosmic exploration," he reflected during a symposium on interstellar objects at the International Astronomical Union. "For the first time in human history, we have the technological capability to study objects that carry direct chemical information between star systems. The insights we gain might fundamentally alter our understanding of how life and consciousness emerge and spread throughout the universe." The future promised encounters with interstellar visitors that might prove even more extraordinary than 3I Atlas. Each object would carry its own chemical signature, its own evidence of the stellar environments and planetary systems where it had originated. Together they would paint a picture of galactic chemistry and cosmic evolution that no single star system, no matter how thoroughly studied, could provide. In the infinite silence that follows the last echo of understanding, where knowledge transforms into wonder and scientific discovery becomes indistinguishable from poetry, the true significance of 3I Atlas began to reveal itself, not as a solved mystery, but as a doorway opening onto vistas of possibility that human consciousness had never before contemplated. The months of observation and analysis had traced the journey of a single object through humanity's cosmic neighborhood, but the implications reached far beyond that limited encounter. If 3I Atlas represented one member of a vast population of interstellar wanderers, each carrying chemical complexity and organizational information between star systems, then the galaxy itself might be understood as a single integrated organism, a cosmic entity engaged in the systematic creation and distribution of ever more sophisticated forms of complexity and awareness. Picture the Milky Way, not as a collection of isolated star systems separated by vast gulfs of empty space, but as a living system in which matter and energy flowed along invisible pathways that connected every world to every other. Interstellar objects like 3I Atlas served as the circulation cells of this cosmic organism, ensuring that the chemical wisdom gained through billions of years of stellar evolution and planetary formation was shared across distances that would otherwise represent insurmountable barriers to the flow of complexity. In this vision, consciousness itself, the human capacity for wonder, understanding, and creative transformation, represented not an accident or aberration, but a natural and perhaps inevitable expression of cosmic evolution. The same forces that guided 3I Atlas on its interstellar journey were expressing themselves through human awareness, through the scientific quest to understand the nature of reality, through the artistic impulse to create meaning from the apparent chaos of existence. Dr. Chen, working alone in her laboratory as dawn approached over Cambridge, found herself contemplating questions that transcended the boundaries of conventional science. If the universe was indeed engaged in the systematic creation of complexity and consciousness, then what role was humanity meant to play in this vast cosmic project? What responsibilities came with the recognition that human awareness might represent one step in an evolutionary process that connected the Big Bang to possibilities that couldn't yet be imagined? The questions had no easy answers, but they pointed toward a profound transformation in how human consciousness might understand its relationship to the cosmos. Rather than existing as isolated observers of cosmic processes, humans might be active participants in the universe's ongoing project of self-discovery and creative evolution. The space program, the search for extraterrestrial intelligence, the development of technologies that could eventually carry human consciousness to other star systems, all of these endeavors might represent natural expressions of cosmic evolution, ways in which the universe was preparing to spread awareness and understanding across galactic distances. But the vision extended beyond human activity to encompass forms of organization and complexity that might emerge throughout the cosmic future. If objects like 3I Atlas truly served as seeds of complexity, then the universe might be engaged in a vast gardening project that would bear fruit on timescales measured in billions of years. Worlds that didn't yet exist might eventually harbor forms of awareness and creativity that would make human consciousness seem primitive by comparison. The thought was both humbling and inspiring. It suggested that every act of understanding, every moment of wonder, every creative leap of human imagination contributed to a cosmic conversation that had been unfolding since the first stars formed and would continue until the last black holes evaporated into the quantum vacuum. As the data from 3I Atlas gradually joined the vast archive of human knowledge, becoming part of the intellectual inheritance that each generation would pass to the next, the object's true gift became clear. It had offered humanity not just chemical complexity or evidence of cosmic circulation systems, but a glimpse of its own cosmic significance, a recognition that consciousness might be the universe's way of coming to know itself. In the gentle glow of vapor trails stretching across millions of kilometers of space, in the patient analysis of light that had traveled impossible distances to reach human instruments, in the quiet wonder of minds grappling with possibilities that challenged every assumption about the nature of reality, the universe was dreaming itself into ever greater awareness. We are not the observers, standing apart from cosmic processes and studying them from a safe distance. We are the continuation, the universe's own capacity for wonder made manifest in minds capable of recognizing beauty, complexity, and meaning in the vast theater of space and time. Through human consciousness, the cosmos contemplates its own nature and discovers possibilities that matter alone could never achieve. And somewhere in the silence between stars, 3i Atlas continues its ancient journey, carrying within its heart the seeds of dreams that will bloom in gardens of stars not yet born, nurturing forms of complexity and consciousness that will, in their turn, gaze out into the cosmic deep and wonder at the magnificent mystery of existence itself. In this endless conversation between matter and mind, between complexity and consciousness, between the universe as it is and the universe as it dreams of becoming, every moment of awareness participates in the ongoing creation of reality itself. The story of 3i Atlas is ultimately the story of cosmic evolution becoming conscious of its own infinite potential, and through that consciousness, continuing to dream new worlds into being. If you found wonder in this cosmic journey, consider subscribing to continue exploring the mysteries that connect us all to the infinite depths of space and time. The universe has many more stories to tell, and each one reveals another facet of the magnificent dream we are all part of.